Hey guys, welcome to this page of the notes. Remember, like I said, what we're now going to do is take a look at the relationship between the exterior angles of a triangle. We just got done in the previous pages looking at the interior angles of a triangle. Now we want to take a look at the exterior angles, and it's actually a pretty simple idea, and I've got a diagram for you here because pictures are always better than words. So here's what we're going to do. If you're given an exterior angle, and here's the way you draw an exterior angle. It's really pretty simple. You have a triangle, this guy right here in blue. All you're going to do is take one of the sides of that triangle, take one of the sides, and just extend it a little bit further. Extend one of the sides of the triangle, right? And you get an exterior angle. Now, what this theorem says is this. This exterior angle, the exterior angle is equal, right, equal to the sum, that means add, the sum of the remote interior angles. Now, remote is a really fancy word you probably have never heard before. Don't worry about it. Here's all it means. Exterior angle, find the two interior angles that are opposite from it, right? This guy, this interior angle is adjacent. It's right next to. That is not remote. You want the exterior angle and its two remote angles, the angles that are opposite that exterior angle, as far away from it as they can get, right? So here's my exterior angle. In order to find the exterior angle, find the two remote interior angles, add them together. That's it. It's just that simple. Now, I've given you a couple of definitions right here for exterior and remote interior angles, but again, the picture really says everything you need to know. You have your exterior angle, find the two remote interior angles, the angles as far away as you can get, add them together. You add them together, you've got the exterior angle. One quick note here before we do a couple of problems, and it's this. Please notice, oops, sorry, I apologize, that's my highlighter. That is not what I want. There's my blue triangle. There we go. Okay, please notice my exterior angle and this adjacent angle, not the remote interior angle, but the adjacent interior angle, the one right next to my exterior angle. Those two angles have to sum to what? This guy right here and this exterior angle out here have to sum to, yeah, that's a straight line. They must sum to 180 degrees. This is really kind of an important idea, so I'll write it right here. The adjacent hope I spelled adjacent right. The adjacent angle plus the exterior angle equals 180 degrees. Guys, it's really just a fancy way of saying the adjacent interior angle and the exterior angle, they're a linear pair, right? These guys right here are a linear pair. Right? These two angles, right? They're a linear pair. You add them together, you get 180 degrees. So, really important idea here is simply this. The exterior angle is equal to the sum of the remote interior angles, and once you know the exterior angle, its adjacent angle sums to 180. That's it. That's all we need to know. Let's do a couple of problems just to make sure that we've got it. Okay, I've given you a diagram, and I want you to determine the measure of all the missing angles. We're going to find all of them. Well, here's what I know. 60 and 40. Knowing 60, knowing that this angle is 60 and this angle is 40, what can I do? Well, there's several things I can do. First, what do I know about the interior angles of a triangle? Well, 60 plus 40 plus, I don't know, has to sum to what? Yeah, you got it. They have to sum to 180 degrees. So, I know that 60 plus 40 plus, let's go and throw an x in there, plus x have to equal 180 degrees. Well, that's not too bad. 60 and 40 gets you 100. Subtract the 100 to the other side, and x has to be 80. All right, well, let's go ahead and throw that in there now that I know it. I know that guy's 80 degrees. Now, there's a couple of ways to do the rest of these, right? How do I find these exterior angles? In fact, let me go and put some color in them so you know which ones we're trying to find. We're trying to find that one, and that one, right? How do I find those exterior angles? You got two options. You know, like we said above, the adjacent interior angle and the exterior angle have to sum to what? Yeah, they're a linear pair. They have to sum to 180 degrees, right? You also know the exterior angle is equal to the sum of what two angles? The remote interior. If this is my exterior angle, that's my remote angle, that's my remote angle. Add them together, I know the exterior angle. Either way, doesn't matter which way you do it, right? If this is 180, subtract 80, I get 100. If this is my exterior angle, 60 plus 40, you get 100. So I know this is 100 degrees. Awesome. Keep going. This guy right here, exterior angle, has to be equal to the remote interior. Well, 80 and 40, 120. 120 degrees. And one last one, here's my exterior angle, equal, right? Equal to the sum of the remote interior angle, so I could do 60 plus 80, or these two angles have to sum to 180. They have to. So 180 minus 40, 140. Either way, you get the exact same answer, and it's nice to have options, right? More than one way to do this triangle, right? So, awesome. Here we go. Got another one for you here. Okay, fantastic. I want you to find the measure of the missing angles, right? Well, here's what I've got. I tell you this exterior angle is 145 degrees. What else do you know? Well, this remote interior angle is 2z. This remote interior angle is 5z minus 2. Well, what do we know about those guys? Add the remote interior angles. Add them together. It has to be equal to the exterior angle. So set it up. I know that 5z minus 2 plus 2z, right? This remote interior and this remote interior must sum to 145. Okay, well, a little bit of simple algebra here. 5z plus 2z, yeah, how about 7z minus 2, 145 degrees. Add 2 to the other side, so 7z equals, how about 147? Let's divide both sides by 7. Divide both sides by 7. 147 divided by 7, I get 21. Right? Z has to be 21. Now, if I go ahead, right, if z is 21, let's go ahead and find these guys then. 2z is going to be equal to 2 times 21, which 2 times 21, what do I get? I get 42 degrees. This one, 5z minus 2 is going to be equal to 5 times 21 minus 2. 5 times 21 minus 2, I get 103 degrees. So this has to be 42. Again, calculator, right? 5 times 21, subtract 2. Use a calculator. So 42, 103. Now, here's the beauty, right? I now know these two angles. How do I find the third one? You have two options. Two options. You know the sum of the interior angles of a triangle must be 180. Or this exterior angle and this interior angle form a linear pair. They have to sum to 180. Either way you do it, you're gonna get the exact same answer. I like this one. So, actually, I apologize. That's gonna wind up squeezing, and I don't wanna do that. 145 plus, I don't know, let's call that angle y, plus y is equal to 180, right? I know that this exterior angle and the adjacent interior angle have to sum to 180 degrees. They have to. Well, subtract 145 to the other side. 180 minus 145, I get 35 degrees, right? So this guy right in here has to be 35 degrees. You could have done the exact same thing by adding 42 plus 103, 42 plus 103, subtract that from 180 to find your missing interior angle. You'd have gotten you would have got 35 degrees. Either way, two different ways of doing the exact same thing. All right, let me erase that so that I am not having to squeeze. I got one more for you here. Let's try this one. Okay, I want you to find the missing angles. So what do I know? Well, it looks like I've given you an exterior angle, and without maybe realizing it, right, what does that little square mean? Yeah, go ahead and put it in there. You know that that little square means that guy is 90 degrees. 90 degrees. That is a remote angle, and there's my other remote angle. If I add these two angles together, they have to be equal to my exterior angle. So that's exactly what I'm going to do. 90 plus 90 plus x plus 2 has to be equal, right? If I add the remote interior angles, they have to be equal to what? My exterior angle. 3x minus 8. Well, here we go. Let's go ahead and solve this guy. Oh, sorry. There we go. All right. 90 and 2, how about 92? Plus x. I'm going to subtract the x, right? It's a plus x, so I'll subtract it to the other side. So 90 is equal to 3x minus x, 2x. Add the 8. Well, that's 90 plus 8 is 98. So what do we get? 98 divided by 2? Wait, did I? I'm sorry. Hold up, I apologize. So sorry. You probably caught my mistake. I wrote 90 here, but it's 92. So I have 92. I'm going to add 8. 92 plus 8 is 100. Whew, I almost goofed. So close to goofing. All right, divide by 2, and we get x is equal to 50. Okay, fantastic. Now that I know that, let's run through here and figure these guys out. X plus 2 is equal to 50 plus 2. So I know that that one is equal to 52 degrees. Great. 3x minus 8 is going to be equal to 3 times 50 minus 8. 3 times 50 would be 150 minus 8. How about 142 degrees? So this is going to be 142 degrees. That is a terrible 142. You probably can't read it. Let's try again. That's a little bit better. And then finally, the only other angle I need to find is this guy. Again, there's two ways to do it. You can either recognize these are a linear pair. So this angle, the one you need, plus this angle have to sum to 180. So 180 minus 142 would get you that guy. Or 90 plus 52 plus whatever this guy is has to be 180. Whichever way you decide to do it, you should wind up with 38 degrees. 38 degrees, right? More than one way to do the problem. Okay, I really like these a lot because we're using both the relationship of interior angles of triangles, exterior angles of triangles. We got all kinds of things going on here that are a lot of fun. Plus, we're even doing algebra. I mean, we're doing some serious math here. Hopefully you're having a good time. I got a few more problems for you guys on the next page of the notes, so head on over. I'll meet you guys there.